For centuries, free kicks have been a devastating weapon in the game of soccer. From solid strikes to curved shots, they can be used to fool the goalie. However, the angle of impact, acceleration, and velocity of the kick all affect the spin that the ball will have. The first kick shows a free kick struck with the inside of the foot, forcing a vicious right-to-left curve. This second video shows one struck with the outside of the foot, forcing a right-to-left curve from lefty Roberto Carlos. This is noted as one of the greatest free kicks in soccer history. These two kicks show the curve of the ball when you kick it with the inside of your foot. If you properly get under the ball while you kick your foot in the right direction, a counterclockwise spin will be produced, forcing the ball to curve from right to left. What takes place is the spin induces a Magnus lift force and has a drag force behind the ball. These two videos show me kicking the ball using Mikey as a center point to show how the ball initially curved from right and back to left. The drag force is going with the spin, forcing the ball to spin, and the forward momentum of the ball is forcing the ball to curve from right to left. This picture diagrams the Magnus force as it relates to our kick. We kick the ball, forcing this counterclockwise spin while the ball is moving forward. The drag force is left behind the ball, and the Magnus lift force is forcing the ball to curve from right to left. We decided to further examine the free kick using physics program Tracker. Using this technology, we traced the center of the origin and plotted the points following the ball's trajectory. We found that the initial velocity was 17.245 meters per second. Here's how we got other calculations regarding this kick. We deduced that the 18-yard box plus the semicircle are 22 yards from the goal and attempt to calculate the kick's overall velocity. 22 yards translates to 66 feet, and 66 feet translates to 20.1168 meters. The total kick time using Tracker was 5.907 seconds. Divide 20.1168 by 5.907 and you get 3.4055 meters per second. This value represents the initial velocity of the kick. Another simple calculation that can be done is calculating kinetic energy. The equation for kinetic energy is 1/2 mv squared. This is 1/2 times your mass times your velocity squared, which yields joules. With our equation, we plugged in 1/2 times the 0.41 kilograms of the soccer ball times the 17.245 initial velocity of our kick. This yielded 60.965 joules. Another simple calculation that can be done at the initial moment of impact is momentum, using the equation mass times velocity. The mass of a regulation soccer ball is 410 grams, or 0.41 kilograms. The initial velocity, as calculated by Tracker, was 17.245 meters per second. Using the equation, multiply 0.41 times 17.245, and you get 7.07 kilogram meters per second, which is your momentum.